Introductory chemistry courses tend to focus on two definitions of acids. The first, which was historically the first, is the Arrhenius definition, which states that any substance that produces hydrogen ions when it dissolves in water is an acid. These hydrogen ions give acids their characteristic properties, such as a sour taste and the ability to corrode most common metals. Another definition is the Bronsted-Lowry definition, which states that an acid is a compound that donates a proton. So the Arrhenius definition is only related to what happens when something dissolves in water, whereas the Bronsted-Lowry is more comprehensive. So let's look more at what we mean by a proton donor. We know that proton is a subatomic particle, but H+, which we refer to as the hydrogen ion, is actually a proton. So let's look at why. A hydrogen atom contains one proton and one electron, and typically no neutrons. So when the H+ ion is formed, it means that the hydrogen atom has lost one electron. So that means that all that is left is a proton. When a proton is dissolved in water, it is highly attracted to the partial negative end of the water, which is the oxygen that has two lone pairs. One of these lone pairs will actually donate its electrons to the proton to form a covalent bond, and this polyatomic ion known as a hydronium ion. Hydronium ion has three covalent bonds from the oxygen to the hydrogen and an overall positive charge. Chemists often use the term proton and hydronium ion interchangeably. An Arrhenius base is a compound that, when it's dissolved in water, forms hydroxide ion. Many Arrhenius bases are from the group 1A and 2A hydroxide salts. Sodium hydroxide, potassium hydroxide, lithium hydroxide, and calcium hydroxide are all examples of Arrhenius bases. These hydroxide bases have a bitter taste and a slippery feel. The Bronsted-Lowry definition of a base is that a base is a proton acceptor.